Standard 10th, Subject Match 2, Chapter number 1, Similarity. Students, let us learn today area of similar triangle. Before that, we will recall properties of ratios of areas of two triangle. Now here you have already learned that the ratio of the areas of any two triangles is equal to the ratio of the product of their corresponding bases and height. That is, A1 upon A2 is equal to B1 into H1 upon B2 into H2. Now, we will learn properties of areas of similar triangle, where we are going to learn S1 upon S2 is equal to H1 upon H2. That is the relation between the sides and the heights of the corresponding triangle. So, the relation between the sides and the corresponding height of similar triangle. So, let's start. Properties of areas of similar triangle, where triangle PQR is similar to triangle ABC. Segment PS is perpendicular to side QR and segment AD is perpendicular to side BC. Now, in triangle PQS and triangle ABD, we get angle Q is congruent to angle B, corresponding angles of similar triangle, and we get angle PSQ congruent to angle ADB, each measure 90 degree. Therefore, triangle PQS is similar to triangle ABD by angle test of similarity. Now students will see, therefore PQ upon AB is equal to PS upon AD, corresponding sides of similar triangle. Therefore, we will get side 1 upon side 2 is equal to H1 upon H2, or we can also write S1 upon S2 is equal to H1 upon H2. Sides and altitudes are in proportion. Now let's see the theorem. Now this theorem states that these are the two triangles ABC and PQR. Here we get the ratio of areas of two similar triangles is equal to the ratio of the square of their corresponding sides. Now given in triangle ABC is similar to triangle PQR. These two triangles are given as similar. We have to prove that area of triangle ABC upon area of triangle PQR is equal to AB square upon PQ square is equal to BC square upon QR square is equal to AC square upon PR square. Now to prove this, we need to draw construction. So draw a segment AM perpendicular to BC and draw segment PN perpendicular to segment QR. Now to prove, let us prove this. Triangle ABC is that triangle ABC upon area of triangle PQR is equal to BC into AM upon QR into PN. Let us consider this one. Now in triangle ABM and triangle PQN, we get angle B is congruent to angle Q, that is corresponding sides of similar triangle. Angle M is congruent to angle N, that is each measure 90 degree. Therefore, these two triangles are similar, which is that triangle ABM similar to triangle PQN by angle test of similarity. Now let's write their corresponding side. AB upon PQ is equal to AM upon PM. Let us consider this as 2. That is corresponding sides of similar triangle. Therefore, we know that triangle ABC is similar to triangle PQR, that is given. So, their corresponding sides are AB upon PQ is equal to BC upon QR is equal to AC upon PR. Let's consider this as 3. These are the corresponding sides. Therefore, we get area of triangle ABC upon area of triangle PQR, which is equal to BC upon QR into AB upon PQ from 1 and 2, which is equal to AB upon PQ into AB upon PQ from 3. Therefore, we get AB square upon PQ square. Similarly, students, we can prove further. Area of triangle ABC upon area of triangle PQR is equal to BC square upon QR square is equal to AC square upon PR square. Let's consider this as 4. Therefore, area of triangle ABC upon area of triangle PQR is equal to AB square upon PQ square is equal to BC square upon QR square is equal to AC square upon PR square from 4 and 3 and 4. Hence, the theorem is proved. Symbolically, the theorem is expressed as if A1 and A2 are the areas of similar triangle and S1, S2 are their corresponding side, then A1 upon A2 is equal to S1 square upon S2 square is equal to S1 upon S2 to the whole square. So student, this is the theorem on area of similar triangle, which you need to practice it. Symbolically also we state here. Now points to remember. These are the important points. Let's take triangle. Area of triangle, we know half into base into height. Now let's take triangle ABC and triangle PQR. Ratio of the areas of two triangle. In triangle ABC, we get BC is the base and AD is the height. In triangle PQR, we get QR is the base and PS is the height. Then we get area of triangle ABC upon area of triangle PQR is equal to BC into AD upon QR into PS. That is, we can also write as A1 upon A2 is equal to B1 into H1 upon B2 into H2. Very good. Now let's see. Here we know that A1 and A2 are area, B1 and B2 is base, H1 and H2 is the height of the triangle. Second, if your H1 is equal to H2, then what we get? Yes, very good. So here we get A1 upon A2 is equal to B1 upon B2. That is, the area of triangle having equal heights are in the ratio of their corresponding bases. You can see these triangles here. If, third one, if B1 is equal to B2, then what we get, students? Yes, A1 upon A2 is equal to H1 upon H2. Now basic proportionality theorem. Here we know if a line parallel to a side of a triangle intersect the remaining two sides in two distinct points, then the line divides those two sides in proportion. That is, if in triangle ABC, line PQ parallel to side BC, then AP upon PB is equal to AQ upon QC. Then we see next converse of PPT theorem. Here we know if a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. That is, in a triangle ABC, we know that line L intersect the side AB and AC in point P and Q respectively, and AP upon PB is equal to AQ upon QC. Then the line L is parallel to the side BC. Let's see next, that is angle. Every point on an angle bisector is equidistant from the sides of that angle. You can see properties of angle bisector of a triangle. In triangle, the angle bisector divides the side opposite to the angle in the ratio of the remaining side. That is, if in triangle ABC RACE bisect, then triangle ACB and A dash E dash B, then we get AE upon EB is equal to AC upon CB. Now we will see next, that is the properties of three parallel lines and the intercept made by them. Now we know that the ratio of the intercept made on a transversal by three parallel line is equal to the ratio of their corresponding intercept made by on any transversal by the same parallel line. That is, if line L parallel to line M parallel to line L, then we get line X and line Y are the transversal intersecting this line in point ABC and PQR respectively. Then we get AB upon BC is equal to PQ upon QR. Now we will see test of similarity of triangles. Angle, angle, angle test. You can see in the diagram. For a given 1-to-1 correspondence, two triangles are similar if the angle of one triangle are congruent to the corresponding angles of the other triangle. Angle, angle test. You can see the diagram. Here we know for a given 1-to-1 correspondence, if two angles of triangle are congruent to corresponding two angles of the other triangle, then the triangle are similar. Then side angle side test. Look at the diagram. You will know that for a given 1-to-1 correspondence, if two sides of a triangle are in proportion to the corresponding side of the other triangle and corresponding includes angles are congruent, then the triangles are similar. Let's take side 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 test. Look at the diagram. You will know that for a given 1-to-1 correspondence, if the sides of one triangle are proportional to the corresponding side of the other triangle, then the triangle are similar. Let's take next here. Area of similar triangle. We know that these two triangles are similar. So the ratio of areas of two similar triangles is equal to the ratio of the squares of their corresponding side. That is, if triangle ABC is similar to triangle PQR, then we get area of triangle ABC upon area of triangle PQR is equal to AB square upon PQ square is equal to BC square upon QR square is equal to AC square upon PR square. Thank you.